Okay, now for the second case, where I need to apply only here uh, the case 2, when uniformly distributed load over the edge value equal to 400, and this value is a resultant of the reaction at the same edge computed in the case 1 and the assumption of linear elasticity. So in the assumption of linear elasticity, we need to find out the results of the reactions and then and apply as a distributed load over the edge. This is called a load control. This is called as a load control. So let's go down here. If you remember that a case 1 was elastic behavior, let's get a result for it. Let's get the result. Now let's find out the reaction value here. So you go to Tool, XY Data, Manager. You go to Create, ODB file, Output, Continue, Unique Node. You want to click here, Unique Node, get RF2 in Y direction. Click here, Node set, no, sorry, view port, edit selection. So I will select these edges, the top, say done. Okay, and this reaction R2, and then save as, and okay. So I need to sum up all the values. You go to create, operate on X data Y, continue, click here, and you go down and find the summation. You highlight all these values and you add a description, divide it here at the end by 1000 to convert to kilonewton, and save as, and okay. You go here, by double click, you will have the value of 625.268 times kilo newton. So this is a resultant of the reaction forces. Now what should I do is, let's close this one and let's delete everything, we don't need it. So please take the notes of this value. Now delete everything, I don't need it anymore. Close and close and close it. Now if you go back here into the load applied is a displacement load. Now I need to apply a pressure load. So if you click in the boundary and you go here, prescribed displacement, so you delete it because we don't need it anymore, and you said yes. Now I need to apply a pressure load, so you go into load manager, you go to create and keep it as a load pressure and click on the pressure and say continue. It will ask you where do you want to apply it. Of course I'm gonna apply on the top here and say done. Now what is the value of pressure? We said that the resultants get given by the elastic analysis in the case 1 was 625.268 kilonewton. If you multiply this value by 1000 and then you need to divide it by 200 as a distance at the length is 200 by the 4 millimeter, the thickness will give you the pressure. So if you go here, so you're gonna say equals to 625.268 times 1000 convert to kilonewton divided by 200 as the width of the plate times 4, which is the cross section area of that plate, and for the thickness that's 781.585 Newton per millimeter square. Note this point, note it. Now The value is minus 781.585. Minus because this is a pressure, so if you click on, yeah, okay, you will see the pressure goes up. Answer dismissed it. Now, let's go to property. And if you click on the property here, and you have plasticity. So I will run this model only for plastic analysis. Only for plastic analysis. To see the differences between elastic and plastic analysis. Differences between plastic analysis for the case 1 and plastic analysis for case 2. When the case 1 is when you applied prescribed displacement, and the case 2 when you applied load or pressure. You keep the mesh as it is. If you click on the assembly, you will see the mesh, and then save the model, and let's start a job. So create case 2 plastic. So say continue and said okay, and let's run the model. You notice this increment getting smaller. And it seems the analysis stuck around the point 0.335, and the increment getting smaller. It seems there is a convergence problem occur here, that particular case. You see the increment become very small, and we cannot continue the analysis. It seems to it means that until under applied load, which is under applied the pressure load or that load, that we attain the maximum load, maximum capacity. So let's wait more. So it's just getting smaller, increment be getting smaller. Where we go? So time increment required is less than minimum specified. So this 10 power minus 5 was a minimum, but let's see the results, which I say it is aborted, which means that it cannot continue the analysis. But it doesn't mean that cannot continue, this is not correct. This means that the analysis cannot be continued because it attained the ultimate load of the plate. So I close it and get the result. You notice this very crucial thing, that when you apply pressure, so the behavior become totally different. So that's gonna be free to move around, while when it was displacement become different. So let's take it the deflection relationship. Let's go to tools, XY data manager, create ODB file output, continue. You need RF2, go here, edit selection, U1, done, save, okay, and create, operate XY data, continue, click on here, sum, highlight all, add it to expression, divided by 1000, then save as, and okay, double click. Oh, there's no load. Yeah, why is no load? Because we click here, it's not here, you have to click it down. Sorry, let's delete all. Let's go back, click this one, let's go back. So I need to edit selection, click out. So we click, the bottom is reactions, you click all, sorry, and done, then save as, and okay, create, operate XY data, continue, and you get here, sum, highlight all, add to expression, divided by 1000 at the end here, and okay, double click, of course, so negative. Let's get the whole reactions, forces, copy them. Let's put them here, for example, for a moment. Okay, let's take the absolute value, copy, Okay, it's a positive value. Now cancel this, delete everything I don't need, delete everything except the force, and delete this one also. Let's find out the displacement at the top here. You go look this one, you go into unclick here, you click on the U to click here, edit selection, and you click that node, and done, save as, and OK. Now that you displacement, double click, and let's take it. Do you notice something interesting, that displacement is U2? Yeah, that is U2, displacement U2, and it's and this displacement. Now if you draw the load displacement relationship, copy here and just draw it over with this graph. You click on this graph here, paste, special paste, Y, and OK. Interestingly enough, that it goes into the ultimate load, which is 210 kilonewton, almost very close to very similar behavior. One minute. Okay. So previously the load 625 is not the full load can be applied in the element, so the maximum load was 210, as you can see here. Okay, so by comparison they get almost the same behavior if you have displacement control or load control. Sometimes the load cannot be continue, so not everything a ported means is not working means that it's got an ultimate load. Thank you very much.